Let us go to the next part of our lecture, that is conservative force. What is conservative force? What comes to your mind when conservative force comes into picture? Varun?
I don't have any idea, sir.
Conservative forces,
That can be conserved.
no, forces which are responsible for conservation of energy of a given system. Are called as conservative forces. This is one important point. And then work done by a conservative force between one initial point and final point does not depend upon path. Okay. The third point is, okay, second point I'll explain you first. Suppose there is a position 1, there is a position 2, okay. Varun? Varun, are you there? Varun?
Sir.
Work done by conservative force between one initial point and final point. Suppose this is one point to another point. If a particle is carried from 1 to here in this path, okay?
Yes, sir.
This is another
Yes,
path
sir.
like this, okay?
Displacement.
Yes, sir.
Another path like this. So in this work done, W1, think this is W2, this is W3, okay?
Yes, sir.
Yes,
So
sir.
if force is a conservative force, if force is conservative force, then the important point is, got it?
Yes, sir.
Yes, sir.
If it is a conservative force, work done in all these paths, initial point is same for both of them, final point is also same or not?
Yes, sir.
Then initial position and final position it will depend upon. It will not depend upon the path that is followed. So work done by the conservative force in path 1, path 2, path 3 is equal. That is W1 is equal to W2 is equal to. Because for 3 paths, position 2 and position 1 are same. Final position and initial position are same. So this is the second point explanation. Third point explanation is, 1 year this question is asked in NEET exam. W1 is W1 greater than W2 greater than W3, W1 less than W2 less than W3, W1 greater than W2 less than W3, W1 is equal to W2 is equal to W3. Directly this is answer.
Yes, sir.
Another point is, work done the closed path, how much it should become?
0.
How do you know? Varun?
I studied in first year.
Huh?
First year, I studied in first year, sir.
Why it is 0? You see here. Suppose closed path I am drawing from here to. Okay.
It starts and ends at same point, sir.
You see here. Suppose you consider this as 1 and this consider as 2 point. So this is W1 and this is W2. Okay.
Yes, sir.
So W1 and W2, suppose if I draw like this, if I draw the arrow like this, W1 and W2 are equal or not? I'm writing this as W2 dash, okay? This 1 to 2 and 1 to 2, both the paths are same. It is independent of path or not?
Yes, sir.
Yes, sir.
It is W1 is equal to W2 dash.
Yes, sir.
But you see, W1 initial point is this one, final point is this one, W2 dash. But W2 initial point is 2 and final point will be 1.
1.
Can I write it as W2 dash can be written as minus W2?
Yes, sir.
So W2 dash is reverse path of W2, that's it.
I think I've read this in thermodynamics, sir.
No. Thermodynamics, actually it will not be 0.
Okay.
If you keep it as 0 in the closed cycle, then your answer is wrong in thermodynamics.
Okay.
Okay. So W1 plus W2 is equal to 0 or not? You got it?
Yes, sir.
Yes, sir.
Why in a closed path from 1 to 2 and 1 to 2 will be work done will be same. But 1 to this is nothing but reverse of W2 or not?
Yes, sir.
Yes, sir.
Just reverse of is minus W2 dash can be written as minus W2. That means W1 plus W2 is equal to 0 or not?
Yes, sir.
W1
Yes, sir.
plus W2 is nothing but what? Cycle or not?
Yes, sir.
Yes, sir.
In this closed path, work done is equal to 0. Now coming to your first point. Forces which are responsible for conservation of energy of a system is, you see here, suppose in our topic at least in our first year topics, you will see gravitational force, spring force is a conservative force. Okay? In secondary topic, electrostatic force is also a conservative force. Okay.
Yes, sir.
Yes, sir.
Now, if you throw a ball, for suppose from the ground, if you give some energy to the ball, kinetic energy, so the ball will slowly go upwards, is right? Ujjwala.
Yes, sir.
Again, finally at this point, kinetic energy will become 0 or not, topmost point.
Yes, sir.
Yes.
But again, the ball is coming downwards. The kinetic energy, when the ball comes here, again it will be equal to the initial kinetic energy or not?
Yes,
sir.
sir.
What did gravity do? Gravity, some energy is lost initially, and again that energy has come back or not?
Yes, sir.
Yes, sir.
Energy completely lost from the system.
Yes, sir.
That energy is
Yes, sir.
conserved or not?
Conserved, sir.
Yes, sir.
But you might ask me, sir, in this world, everything is conserved. Energy can neither be created nor destroyed. It is conserved. That is law of conservation of energy.
Yes, sir.
Then
Yes, sir.
what is conservative force and non-conservative force? Will you get doubt or not?
Yes, sir.
Yes, sir.
So I'll tell you another situation. What is this conservative energy is? Suppose there is a block here. You give a kinetic energy. Suppose it is frictional surface. Okay? So now this block is traveling like this. After initially some velocity is given. Finally it comes to rest, right?
Yes, sir.
Yes, sir.
Because of friction, this velocity will decrease or not?
Yes, sir.
This
Yes, sir.
kinetic energy is converted into heat energy or not because of friction.
Yes, sir.
So that is energy is conserved here. Matlab whatever the kinetic energy that is lost is converted into heat energy. Okay.
Hmm.
So that the block temperature also might rise.
Okay.
Okay. You see, that's why you, like this if you do, your hand will feel
Hot.
mechanical energy is there that is converted into heat energy in your hand.
Yes, sir.
Mm-hmm. Yes, sir.
So now, but can you bring back that heat energy to kinetic energy again easily? You see here, ball is thrown, it went to the topmost point. Again, the kinetic energy has come.
Yes, sir.
Yes, sir.
Ball goes upwards and again it is coming downwards. And it is getting the kinetic energy again or not? Gravity is giving it the kinetic energy is again or not?
Yes,
Yes,
sir.
But in friction, is it happening?
No, sir.
No, sir.
It is converted into heat energy. Energy is conserved. But can that heat energy again come back to kinetic energy easily?
No, sir.
Varun,
No, sir.
so here also conservation happens, non-conservative also. Conservative also conservation happens. But the conservative force main important point is the energy will not be completely lost. It can be easily regained, that form of energy.
Okay.
Okay, sir.
Now you might ask me, where will it store? Whenever conservative force comes, so this kinetic energy will be converted into something, and again that kinetic energy has come back when it came to this position, right?
Yes, sir.
Yes.
So this kinetic energy, that conservative force will store in how much? Where will store in as?
Potential energy.
That is why potential energy will come into picture only when there is
Kinetic energy.
Kinetic conservation.
here kinetic energy is there. It will store when it is going upwards. It will store in.
Potential energy.
Energy.
And again, while the ball is coming down, that potential energy tank, that energy is again taken out.
Yes, sir.
So this conservative force is storing here. But will the heat energy stored here?
No, sir.
So
No, sir.
friction is a
Non-conservative.
Non.
understood law of conservation of energy, and this both the forces, their difference, light trick is there.
Okay.
Yes, sir.
That is why whenever conservative force comes into picture, their potential energy comes into picture.
Yes, sir.
Like
Yes,
the
sir.
spring is there, for suppose you see. So initially spring has got some velocity, for suppose. Slowly the spring will go here and the velocity will become zero or not.
Yes, sir.
So
Yes, sir.
kinetic energy is lost. That kinetic energy is converted into
Spring force.
spring potential energy,
Okay.
Yes, sir.
isn't it?
Yes, sir.
Spring potential energy. So this spring force is also a
Conservative force.
Conservative.
but whereas friction is
Non-conservative.
viscosity, these are all non-conservative
Non.
forces. Got it?
Yes, sir.
Yes, sir.
Did you understand the difference between conservative and non-conservative?
Yes, sir.
Yes,
What is
sir.
the important point? Forces responsible for conservation of energy in a given system.
Okay.
So what happened here in friction? From this system, it is converted into heat energy to other system. That heat energy cannot be easily retained back.
Yes, sir.
But whereas here it is converted into potential energy in the system itself, and that is again converted into kinetic energy very easily.
Yes, sir.
Yes, sir.
That is why whenever conservative force is there, potential energy comes into picture. One point is conservative force is responsible for conservation of energy in a given system. Other point is there is, if conservative force comes into picture, potential energy comes into act. Other point is work done in all the paths. If initial position and final position are same, work done in all the paths is same. The work done in a closed path is zero. These are the main points of the conservative forces.
Yes, sir.
Yes, sir.
For non-conservative, in a given system, energy is not conserved. It will go to other system, but it will not be easily retained by that. So potential energy does not come into picture. For a non-conservative force, potential energy is not related.
Yes, sir.
Friction do not have friction potential energy. Okay. Gravitational potential energy will have, spring potential we will have, electrostatic potential energy will have, but friction potential energy will not have. Viscosity potential energy will not have.
Yes, sir.
Yes, sir.
Next. Then work W1 not equal to W2 not equal to W3 in non-conservative forces.
Non-conservative.
Work done in a closed path is not equal to
0.
0.
You might have studied for 4-mark question maybe.
Yes, sir.
Yeah. Remember, you understood the point, 4 points, how I told.
Yes, sir.
Yes, sir.
Then the important part is relation between, I told you conservative force and potential energy, there is a relation.
Yes, sir.
Yes, sir.
Relation between conservative force and potential energy. That is delta U is equal to minus change in potential energy is equal to negative of work done by conservative force. Negative of work done by,
Conservative force.
I'll
Yes,
show
sir.
it. The standard example that I'm giving you all the ways. Suppose a ball is thrown upwards with a velocity u. Slowly, you see here, the ball has displaced by distance h. It has gone up. So now you see,
Yes.
gravity has done work on this or not?
Yes, sir.
Yes, sir.
Gravitational force is how much? mg
M.
downwards. And displacement is upwards. So that is cos of 180. That is nothing but what? Minus
-1.
h or not?
Yes, sir.
Yes, sir.
Gravitation has done work done negative means what will happen? The energy will decrease or not? Kinetic energy.
Yes,
Yes,
sir.
sir.
So now the energy is decreased or not? Slowly, kinetic energy.
Yes, sir.
Yes, sir.
But you know this. If kinetic energy has decreased slowly because gravitational is a conservative force, that energy will be stored somewhere or not?
Yes, sir.
Yes, sir.
Where it is stored is the storage tank is what?
Potential energy.
Potential energy. So potential energy, how will you write with respect to this point?
MG.
mgh
Yes.
or not? Yes, you see, gravitation has done negative work or not?
Yes, sir.
Kinetic energy has decreased, but that is how much ever the kinetic energy is decreased, that is converted into potential energy or not?
Yes,
Yes,
sir.
sir.
Like suppose you see there is a groundwater is there. How much ever groundwater is taken out in the pipe, that much water is stored in your tank or not, on the topmost tank.
Yes, sir.
Yes, sir.
So if you are taking energy from ground, that is taking energy is what? Negative work or not?
Yes, sir.
That means positive energy is stored in where? Tank or not?
Yes, sir.
So
Yes, sir.
potential energy is that kind of tank. If you do negative work, potential energy will become positive.
Positive.
Suppose you see, again from tank you are using tap water. So slowly it converted into, this ball will come downwards. You see, the gravitational force is mg. H displacement is also in the same direction. Cos 0 is 1. So mgh is the work done or not?
Yes, sir.
But potential energy will be decreased by minus mgh or not? Check.
Yes, sir.
Yes, sir.
So what is the relation? So work done is positive, that means potential energy is negative. Work done is negative, potential energy is positive.
Positive.
Work done is negative means what? You're taking energy from it. And you're taking and you're keeping in your storage tank. Potential energy will increase or not?
Yes, sir.
Yes, sir.
If you're doing positive work means you're giving energy or not?
Yes, sir.
If you're giving energy, you're taking from your tank.
Yes, sir.
It's like, or I'll try to simplify it more. if you're giving energy to the system, that means you are taking from your tank.
Yes, sir.
That
Yes, sir.
means if you're doing positive work, potential energy will decrease. If the force is doing negative work, potential energy will
Decrease.
increase. You're
Increase.
taking energy from the system. You'll store in potential energy.
Okay.
Yes, sir.
That means change in potential energy is equal to minus of work done by conservative force. This formula is apt or not?
Yes, sir.
Yes, sir.
This formula is such an important formula. You need to remember. Delta U is equal to minus of work done by conservative force. 5-star formula. Okay. Okay. You ready?
Yes, sir.
Shall I go ahead?
Yes, sir.
Now, the part of it is gravitational
Potential energy.
potential energy. First thing you see here. Suppose in gravitation, this is first position. This is number 2 position. You have taken the particle like this in this path.
Okay.
So I'm just considering. And another important point you need to remember is for potential energy is always reference point is required.
Yes, sir.
Otherwise, you cannot. It is a reference from one point to another point. Because conservative force you will do from one point to another point, right? Work.
Yes, sir.
That is why reference point is always important. You see how it is shown. So I'm taking here. What is the work done by gravity here? I'll see. Okay.
Yes, sir.
Here I will take the displacement, some vectors like this, because here displacement is varying, right? Entirely.
Yes, sir.
I'll take the any one part of displacement vector like this. The displacement vector, ds vector. So can I take this ds vector in 2 components? One is horizontal and one is vertical.
Yes, sir.
So this is, I'll write it as, this vertical is parallel to gravity or not? Anti-parallel or parallel? Because gravity will be vertically downwards, right?
Yes, sir.
This I'll write it as ds parallel. This I'll write it as ds.
Perpendicular.
So can I told you right in vectors, this
Yes,
vector
sir.
plus this vector is equal to this vector or not?
Yes, sir.
Yes,
So
sir.
ds vector can be written as ds perpendicular plus.
DS parallel.
So work done is equal to gravity, at least for small distances. Gravitational force is constant or not?
Yes, sir.
Work done is equal to what? Force due to gravity dot displacement or not?
Yes, sir.
So this can be written as force due to gravity is how much? Mg dot
GH.
displacement is how much? ds perpendicular plus ds parallel, right?
Yes, sir.
So these 2 vectors are there. You see mg dot ds perpendicular, this gravitational force dot ds perpendicular, how much, what is the angle between ds perpendicular and mg? Varun, you tell me.
9.
Varun,
Sir.
ds perpendicular is like this.
90 degrees, sir.
Nine.
Gravity will be like this or not?
Yes, sir.
90.
Both of them will have an angle
90.
90. So this will become 0 or not?
Yes, sir.
Yes, sir.
mg into ds parallel is how much?
0. The
Ds
angle is 0.
So parallel is not 0, right? Parallel
Yes,
you will have. No? So mg into ds parallel or not?
Yes, sir.
Yes, sir.
If I integrate ds perpendicular, all components work done is 0. If I integrate means what? Parallelly, if I integrate, mg is a constant force, right?
Yes,
Yes,
sir.
sir.
Work done is equal to mg into ds parallel. Can I write it as? From s initial to s final, right?
Yes, fine. Yes,
Yes,
sir.
sir.
So parallel, if I add all the distances,
Okay.
I will only get vertical height or not?
Yes,
Yes,
sir.
sir.
Will it depend upon this horizontal distance?
No.
No, sir.
Because this perpendicular vector has
Median.
become 0 or not?
Yes, sir.
Yes, sir.
So now, if this I take initial point 1, this I take final point 2. If I take the, so suppose in case reference level, if I take like this, for suppose this one.
Okay.
So from this here, this is H1 height. From here, this is H2 height. Okay.
Yes, sir.
Gravitational work done is what here? mg
mg
into H1 minus,
h.
but here displacement is upwards, force is downwards.
Okay.
If you take H1 minus H2 as capital H, so the answer will become as minus.
Minus mgh.
You got it?
Yes, sir.
Is this the work done by gravity or not?
Yes, sir.
Yes.
But you should remember here, it depends between 2 points. If I take this as reference level, the gravitational work done will be different. Got it?
Yes, sir.
Work done by gravity is equal to minus mgh here. This h is the difference between 2 points. Their reference point is always important.
Yes, sir.
Okay.
Potential energy is how much? Change in potential energy is equal to negative of work done by conservative force or not?
Yes. Yes, sir.
Means negative of work done by gravity or not?
Yes, sir.
Yes, sir.
Negative of minus mgh or not?
Yes, sir.
That is mgh. You got it? But mgh is not absolute.
Okay.
If you take reference levels as different, suppose particle is here, 2 meters distance. So we cannot say the potential energy is mg into 2, okay?
Yes, sir.
If it is considered from this level, which is 5 meters, it will become mg into 5.
Hmm.
If you consider the reference level to be here, 10 meters down, mg from mg into 10, got it?
Yes, sir.
But very important special point in HC Verma on this 2 or 3 questions are asking different points. Difference will remain same. Suppose here particle is taken from here to here, okay?
Yes, sir.
First point and second point, okay? I am taking this to be the reference level, okay? So consider this level is how much meters? Suppose 10 meters for suppose. It will become how many meters? 12 meters or not?
Yes, sir.
Now, what is the change in potential energy? Suppose gravity work done is negative. That means potential energy will become positive or not?
Yes, sir.
Here mg into 12 meters
Yes, sir.
minus mg into
10 meters.
mg into 2 meters or not?
Yes, sir.
So difference, change in potential energy will not change. You might take any reference level, change in potential energy will remain constant, but potential energy will not be same because potential energy will depend on
Reference point. Reference point.
Because this can be mg into 2, this can be mg into 5, this can be mg into 10 depending upon reference. But difference will be 2 meters, right?
Yes, sir.
Yes, sir.
That is why the change in potential energy will not be giving confusion to you. But whenever you ask just simple potential energy, you should ask a reference. What is the reference level here?
Okay.
Okay.
Got it?
Got it, sir.
So then I hope this is clear for you. For any conservative force, work done by conservative force is force of conservative force into delta S parallel, okay?
Yes, sir.
If it is a variable force, we will integrate, right?
Yes, sir.
Yes, sir.
I taught you. If it is variable, we should integrate. So work delta U is nothing but negative of work done by conservative force.
Force.
Got it?
Got it, sir.
Now gravitation I explained to you. Similarly, suppose in that way, if you take gravitation, final conclusion of result. Suppose this is a reference line. What is this? Okay. Reference line. Okay. This is the reference line
Hmm.
where potential energy is equal to 0. If you take this to be 0, for suppose, from reference line, suppose if you're taking h distance upwards, so here the potential gravitational work done from here to here is what, negative or not?
Yes, sir.
The potential energy will become positive. This
Positive.
will become mgh. If you take the reference level h distance below the reference level, okay, gravitational work done is positive or not if you are going downwards?
Yes, sir.
So potential energy will become how much?
Negative.
Got it?
Yes, sir.
This is the understanding you should have. Depends upon reference level.
Okay.
Okay, fine.
Then spring potential energy, can we go?
Yes, sir.
Here, you remember that if it is a variable force, we need to find out work done.
Yes, sir.
Yes, sir.
Integrate by integrating. Here you see spring. Spring force I already explained you, right?
Yes, sir.
So now you see, if you are extending spring from here to, suppose this is natural length. If you are extending spring, natural length force will be 0, right? Because k into x will be 0.
Yes, sir.
Yes, sir.
So slowly if you are extending spring, suppose at a distance of x, the force will be how much? If you extend x distance from natural length, force will be how much?
L plus x. A into L plus x.
No, displacement kx.
Okay.
L plus x will not be taken into consideration. At L length there will not be any force.
Okay.
Okay.
Yes, sir.
Kx will be the force in which direction? Here.
Yes, sir.
Displacement positive, the force is negative. So can I write it as, now I'll try to find out work from initial point, some initial point from here to x initial to x final, okay? So force is how much? Work done by spring force is equal to, force is kx.
Yes, sir.
Yes, sir.
And because this force is varying, right? From x1, kx1 is different. After some distance, this kx2 is different, kx3 is different, kx4 is different, kx5. Everywhere force is varying. Kx final is different, right?
Yes, sir.
So I'll write
Yes, sir.
a random kx, and the force is varying. Varying force means what we should do?
Integrate.
Integrate.
Integration. I took a small displacement dx from a kx. X displacement, I took a small displacement dx. How much work done will be taken? You see here. If the spring is like this is natural length. From the particle is displaced from here to here. So dx displacement I took at a distance x. So force will be how much? Kx. Displacement is how much? Dx.
DX.
Kx dx is the work done. Integral of dx, right?
Yes, sir.
So kx dx, angle between them is what? 180 degrees.
Okay.
So what is
Yes,
that
sir.
answer? -1, right? Cos 180.
Yes, sir.
Yes, sir.
Force is like this, displacement is like this. You see that from x initial to,
X final.
so if you integrate, what will happen? Tell me.
Ws is equal to minus k into x square by 2 from k initial.
X.
X initial to x
Answer
final.
will be minus k by 2 into x final square minus,
X initial square.
sorry, here. Okay. X final square minus x initial square. You got it?
Yes, sir.
This is work done by
Spring force. Spring potential.
carefully listen here. Work change in potential energy. Most of the times work done by spring force will be rarely asked, but your problems will be mostly on potential energy stored in the spring.
Okay.
Okay, sir.
Change in potential energy is how much? Minus of work done by spring force, right? Conservative force here.
Yes, sir.
That is minus of minus k by 2 into x final square minus
X initial
X
square.
initial square.
that will be how much? K by 2. You got it?
Yes, sir.
Yes, sir.
From the same concept, one formula I derived everything.
Okay.
Yesterday I taught you, right? Integration, if we have to do, if you are having the force as not as constant.
Variable. It
Variable
is
force.
variable.
Yes, spring force is a variable force, but it is a conservative force.
Yes, sir.
Yes, sir.
That is why you see here delta is equal to k by 20 x final square minus x square. Suppose in case x initially is 0, that is from natural length you are taking it.
Okay.
Okay, sir.
Delta u is equal to how much?
K by
Half k x square you might have remembered like this. But this is an important part. Okay.
Yes, sir.
I hope this is cleared for you.
Yes, sir.
Yes, sir.
So for initial part is there, suppose like this u of spring force can be written as k by 2 x square. If s1 is k1 k by 2 x1 square, u of s2 is k by 2 x2 square. So delta u is equal to k by 2 into x2 square minus x1 square. Got it?
Yes.
So I hope this is clear. So we'll see in the next class. Okay.
Okay, sir.
Thank you.
Thank you, sir.
Okay.